Okay, we are recording. Okay. It's currently 47 minutes past midnight. I've just got back and I have not done transition metals just yet, which is a bit unfortunate. I don't think we're going to be able to get this section done with the score. I don't think I'm going to have too many questions, but I at least do want to go through the um, the notes. So at the very least, we can go through that. Try and get 20 minutes done, maybe 30 minutes, get us into the yellow, which would be a big improvement because we've basically neglected this whole second half. Okay, let me just move window capture 2 up, and here we go, transition metals. So let's get this going. Um, and maybe at the end I'll play some GeoGuessr because why not? Okay. General properties of transition metals. Transition metal characteristics of elements scandium and copper arise from incomplete D sublevel in ions. And forming ions lose 4s before 3d. Okay, yes, we know that. So they gain 4s before 3d, and they also lose 4s before 3d. These characteristics include complex formation of colored ions, variable oxidation state, and catalytic activity. So I've gone over ligands quite recently, so I think where is ligands and stuff? Is this included here? Nope. Oh, well, yeah, here, this will ligand exchange stuff. This is a long, very long topic, unfortunately. So I don't think I'm going to look at all this today, but maybe just a bit. Okay. Why is zinc not a transition metal? Zinc can only form a +2 ion. In this ion, the zinc 2 plus has a complete d orbital and so does not meet the criteria of having a complete d orbital in one of those compounds. Scandium, I know this as well, can only form a +3 ion. In this ion, the scandium 3 plus has an empty d orbital and so does not meet the criteria for having an incomplete d orbital in one of its ions. That's because it loses the 2 from the 4s first, and then it loses 1 to make the 3 plus, another 1, and because it only has 1 in the d orbital, that leaves it with this outermost subshell still being 3p6 instead of 3d. So therefore, it's an incomplete 3d. It's not an incomplete 3d subshell. The successive ionization energies for elements scandium to zinc show a gradual increase in ionization energy until all the 4s and 3rd electrons have been removed. There is then a big jump as electrons start to be removed from the inner core electrons. Okay, so let me just read through that again. The successive ionization energies for the elements from scandium to zinc show a gradual increase in ionization energy until all of the 4s and 3d electrons have been removed. There is a big jump as electrons start to be removed from the inner core electrons. Okay, so basically it's telling me that 4s and 3d ionization energies are much lower than 3p6 onwards. Complex formation. Complex is a metal ion surrounded by ligands, ligand, an atom, ion, and molecule, which can donate a lone electron pair. Okay, so water, etc. A coordinate bonding is involved in complex formation. Coordinate bonding is when the shared pair of electrons in the covalent bond come from only one of the bonding atoms. Wait, so what's the difference between that and dative? Presumably it's the same. Let's search it up. Is coordinate and dative bond same? Yes, coordinate bonds and dative bonds are the same thing. Okay, that's all I needed. Coordination number, the number of coordinate bonds formed to essential metal ions. So for this, coordination number is 6, because there's 6 ligands. Ligands can be monodentate, e.g. H2O, NH3, or Cl minus, so they just form one bond. Yeah, one coordinate bond per ligand or bidentate, NH2, CH2, CH2, NH2. So both the NH2 groups have a lone pair. So, or both the nitrogens in the NH2 have a lone pair. So I'm guessing that just means well, I know it means it just forms two bonds. Pretty simple. Um, Two coordinate bonds per ligand, or multidentate EDTA 4 minus, which can form six coordinate bonds per ligand. That I remember that. That's the big, weird looking one. Yeah, this is this. I mean, I don't think I remember this. I don't know if I'm supposed to remember it, but it is long and large, and I'm guessing, yeah, it shows, so the highlighted in blue ones form bonds. So here. 6 sides 4 oxygen, 2 nitrogen, and forms a 1-to-1 complex with metal ions. A complex with bidentate ligands, e.g. there are 3 ligands in this complex, each bonding, but the coordination number is still 6. Yeah, it says that there, yeah, so that makes sense. Still forming 6 bonds, just only with 3 molecules. A complex with bidentate ether. Okay, this is another example, but this is useful to know. It comes up, I've seen this come up in exam questions already, so that's useful. Formation of colored ions. Color changes arise from changes in oxidation state, coordination number, and ligand. Yes, this I forgot very quickly. So yellow, aqueous, copper, brown, copper, NH3s. Okay, I am not going to remember this super well. This equation, only oxidation state is changing. Yep, makes sense. Green. Interesting. I like the color green. In this equation, both ligand and coordination number are changing. I can see that H2O replaced by Cl4. Coordination number decreases from 6 to 4. This equation, only the ligand is changing. So coordination number is still 6, but just H2O is replaced with NH3. Makes sense. How color arises. So these are all the things that affect color, I'm pretty sure. How color arises. Color arises from electronic transitions from the ground state to excited states between different d orbitals. Yes, so d to d transition. I remember that is a thing. A portion of visible light is absorbed to promote d electrons to higher energy levels. The light that is not absorbed is transmitted to give the substance color. A portion of visible light is absorbed to promote d electrons to higher energy levels. The light that is not absorbed is transmitted to give the... Okay, that makes sense. Average do not field ligands, octahedral complex ion. Ligands cause 5 d orbitals to split into 2 energy levels. 5 d orbitals. Makes sense. 10 electrons, 5 d orbitals. Makes sense. Solution will appear blue if it absorbs orange light. What's the context of this? Why is it telling me this? Are they opposites? The red was the opposite. Surely it would appear like, I don't know, maybe still roughly, maybe like purple, or no. What's the opposite of orange? Green and blue, turquoise, potentially. That is what I would assume. Anyway, changing color. Changing a ligand or changing the coordination number will alter the energy split between the d orbitals. Hence, changing the frequency of the light absorbed. Makes sense. Compounds without color. Scandium is a member of the D block. Its ion, scandium 3+, hasn't got any d electrons left to move around, so there's not an energy transfer equal to that of visible light. Makes sense. In the case of zinc D+ ions and copper ions, the D shell is full, e.g. 3d10. So here there is no space for electrons to transfer. So there is not an energy transfer equal to that of visible light. Makes sense. Spectrophotometry. I do not recognize this word particularly well. If visible light of increasing frequency is passed through a sample of a colored complex ion, some of the light is absorbed. The amount of light absorbed is proportional to the concentration of the absorbing species. Some complexes have only pale colors and do not absorb light strongly. In these cases, a suitable ligand is added to intensify the color. I thought the light absorbed. I thought if you absorb light strongly, that would make you more pale because you're transferring less. Am I missing something? Electrons, portion of light is absorbed to promote the energy. That light is not absorbed, is transmitted to give the substance color. But I suppose if less energy is absorbed, the energy levels, yeah, the electrons aren't promoted to higher energy levels. I don't know. I don't know. I'm not really sure about that, but okay. Absorption of visible light is used in spectrometry to determine the concentration of colored ions. Add an appropriate ligand to intensify the color. Make up solutions of known concentration. Measure absorption or transmission. Plot graph of results or calibration curve. Measure the absorption of unknown and compare. Okay. Shapes of complex ions. Transition metal ions commonly form octahedral complexes with small ligands. Makes sense. Octahedral because it's basically a cube, right? Wait, what am I saying? Well, these are 90 degrees, and then it's, if I'm drawing out the lines, I mean, it makes an octagon if you just do it 2D, but I don't know associating that. It doesn't really matter. I know what it is. Transition metal ions commonly from tetrahedral complexes, know with that. Square planar complexes are also formed, e.g. cisplatin. Why are they square planar? Do we still have two? Yeah, we still have two lone pairs, right? Or is it? Because if it was one, if it was no lone pairs, it'd be this. But there's still two lone pairs, so it's this. I'm guessing? No, that doesn't make any sense, does it? No idea. Figure it out. Oh, something to do with the chlorine, probably. Ag plus commonly forms linear complexes, e.g., silver, ammon, am, silver ammonia, silver ammonium silveride. I don't know. Regardless. And all of these, which are colorless. Silver forms linear colorless complexes. Interesting to know. Cisplatin. The platinum complex cisplatin is used as an anti-cancer drug. Cisplatin version only works as two chloride ions are displaced and the molecule joins onto the DNA. In doing this, it stops the replication of cancerous cells. In the body, one ligand is substituted by a water molecule. Be able to apply your knowledge of bonding to a given information in the question to explain how it bonds to DNA molecule. Generally a combination of dative covalent bonding and hydrogen bonding. Platin binds the DNA of cancer drugs and stops binding. Cisplatin, transplatin. Can also prevent the replication of healthy cells by bonding onto healthy DNA, which may lead to unwanted side effects like hair loss. Iron 2 in hemoglobin enables oxygen to be transported in the blood. Heme is an iron 2 complex with a multidentate ligand. CO is toxic to humans as CO can form a strong coordinate bond with hemoglobin and replaces oxygen in a ligand exchange reaction. This stronger bond that made with oxygen prevents oxygen attachment to hemoglobin. So this is kind of, we know some of this from biology. And we seriously only 3 pages in. Wow. Okay. What are we on? 15 minutes, to be honest. We've gone through like the basics. These are all specifics. I think we can go over them next time instead of this time. Probably better. So, in that case, I will quickly switch back to this. Give myself this go untested here. Unfortunately. I know this is the least efficient way of doing this, by the way. I just can't really be bothered to set up a thingamabob. So actually we're on 15 minutes, aren't we? So let's go 15 minutes. And then video. Have I watched a video today? No, none. So to be fair, not a huge improvement, but we have a lot of time on this topic. So compared to the other days, it's still definitely an improvement. I mean, 125 minutes total, definitely a big improvement on our highest day is this, which is an hour and a half. 90 minutes with blown out of the water. Wonderful. Oh yes. Some geoguessr. Okay, so yeah, I got this up here. I'm second in the league, so I'm not worried about going down. We've got some unfortunate people down here. 82 games is rough. I mean, gotta have a lot of games played. Only 694, so must have had a pretty big growth. But yeah, we are on 942 elo, 183 duels games, 1027 classic games. Let's hop into some classic games. Not classic maps, community maps. I think I'm going to do some no move on antibiotic. Okay, immediately. I mean, I thought Spain immediately, but actually, not super confident in that. For some reason, these road lines remind me of Greece. I don't recognize this kind of these trees are a bit weird. Is that the sea? Like, why is it nothing there? Eastern Sea. I mean, where would Eastern Sea be here? I mean, it could definitely be east coast of Spain, to be honest. But the road lines, and just the road like quality, maybe makes me feel more Greece. The car doesn't really. The rockiness, I feel like could probably be both. Like I feel like in Spain the boulders are probably like a bit different. Like this rock, no, actually it could really easily be. Got a white water bottle. Nothing much else to go off. It does remind me more of Greece, so I will go Greece, but I'm not really confident in that. I mean, I didn't really know where in Greece this would be. That's the only problem. So it could be like Sardinia. I can see. Oh, we have these like rock walls. Maybe that's less common in Greece. More Sardinia. I think Sardinia actually would be a better guess here. And it's Mallorca. Oh, god damn it. I did think Mallorca, but take what you get. Okay, Northern Sun. I mean, you could kind of guess that. This road is very red, and the road line I can't see. Uh, Not like I wanted to say. Why can't I tell what country this is? Like, why is the canopy not got any eucalyptus in it? Like that isn't, is it? Doesn't look like it. Uh, it's surely not Argentina. Surely not Argentina. This fence, this cactus. Okay, we got a cactus. Definitely leading me away from. Could this be? Nah. Why is the road so red though? Is that not way more common in Australia? Why is the bushes look like this? Uh, and why is the canopy like no, like that? Oh no. I think I have to go Australia on this. It looks weird, but okay, we've got a hill there. Well, now that leads me back towards Argentina because where are you getting a hill like that? Oh, it's possible. It's possible. A southwestern hill. In terms of region guess, definitely would go like maybe South Australia. I don't know. Definitely wouldn't go like Western or Northern really. Right angle is southwest. That's southeast, so it couldn't be there, but I don't know. This might send that in. I don't really know what else to go off here. I mean, yeah, it was Argentina. I mean, I thought it looked. I don't know. Like the trees made no sense. But I just the redness and the yeah, and this makes so much sense with the road quality and like the texture as well. Like, but I just is a thing. Is a thing. Okay, easier round. Definitely Japan here. So quite a lot easier. In terms of where pole plate, why are they like touching? Why are they like literally touching? I don't know. Well, I don't know a lot about poles, so in Japan. Okay, we got. Why is there a plate on this absolutely minuscule pole? Oh, there's on all of them. And they got the reflectors as well. It's like a mini pole. We have a single plate, not telling me anything really. Nothing distinct about this. It doesn't feel very north. I mean, feels actually pretty like temperate, green, hilly, maybe like just Nagoya area. Could even be Tokyo. I would doubt it's Tokyo, but I think I'm just gonna go here. What? Okay. Was not getting Hokkaido there. Did not really feel like it was Hokkaido at all. I guess I didn't know what Hokkaido trees look like. Is this is Peru? Was not thinking Peru immediately, but actually makes sense. So, where in Peru has this much rubbish? Because I did, like, when I looked at this, I did not think Peru straight away. So, but definitely makes sense logically. It's Peru. So, where in Peru is it? Like, why does it look like this? Why does it look like this? I don't know. Click above Lima. Why is it so red as well? Maybe it's more north. Yeah, it was very north. I was thinking north, I just couldn't. Okay, we're on a pretty bad score, so. Hmm, I mean, US. Right. This is US. It's not Canada. Low key could be Canada. Uh, I'm gonna go North Dakota. Road angle is like north. Basically every road. Just gonna go here. Don't know. What's South Dakota? Pretty decent guess. 13.9k might go another round because that was a pretty bad score. Looks like we're in. Like, why does it kind of look like Po Valley? Obviously the road doesn't make sense, but kind of does look like Po Valley. Makes me think Bulgaria. Yeah, I might just have to go Bulgaria here. Northern, maybe. Pretty good guess. Poles, very thick, and very square. Is the sun north? Wait, is it? No, I'm not trusting that. Think you just have to go Thailand, I guess. I mean, I don't know where you click. Somewhere in this flat area, probably. And it was Philippines. That makes sense. Well, the doesn't make sense to the poles, but everything else, it did look more like the Philippines. So they're just made quite hard rounds, actually. Like, I probably could have got that if I sat for a little bit, but was not wanting to do that. Okay, this is a bit of a difficult round as well. Wooden structure randomly. Growing trees, like intentionally. So that immediately basically puts Russia out the window. Not that this looks anything like Russia. We have a deer. That's pretty cool. I wouldn't think I wouldn't think Finland either. I could see Sweden, potentially. I could see not that many other places. Like, could it be that one Czechia, like, forest? Like, I don't know where the exact forest is, but maybe. Could be potentially even France, but I think I'm gonna go Sweden and take the hit if it's not. It was Germany, yeah, that makes so much sense, but I just kind of too scared to commit one place or the other, so what seems obvious. Is that a snow pole? I have no clue what that is. This is actually pretty confusing to me. Why are these rounds so much harder than AI generated world? Southern Sun. Like there's no this is like US. Like I could go wrong continent there because I'm not sure. Like where? I feel like I'll go Europe just because of the road and the hilliness and everything. And the poles, like puts you away from Asia and stuff. So like wouldn't be I don't think it would be some crazy. Nah. In terms of where the soil is really weird for Europe. I think. Maybe not. I don't know, it just feels like it is kind of. Maybe just go Spain. I might just go Spain because this is a terrible guess though because it doesn't really look anything like Spain, but I just can't think of where it could be. Like you wouldn't see. I wouldn't think Italy. I wouldn't think Greece. I wouldn't think Turkey. Yeah, I'll go Spain. It was Turkey. Wow. Didn't really recognize that area. Okay, we got US here. Or is it Canada? Are those low-key Parana pines? We're not in Parana though. I mean, I'm gonna get like a 12K or something if I might say in the wrong half of the country. I'm gonna say this could be like Colorado or something, couldn't it? Realistically, like maybe it is in fact. Like just the way none of this is so many pines. Like I really want to send Colorado. I'll just send the middle of Colorado. Wow, was not Colorado. And that puts us in 11.2k points. I'm definitely gonna play again because I am not happy with that score. Okay. I haven't really registered what's going on here. Is this US? Oh, it's Europe, right? I don't know. Is that us? No. Where on earth is this? Or is it US? Wait, is it? Why am I struggling so much to identify this? Sorry, I'm just checking whether my thing is on. Just like a lot of my screen is not visible. But I don't know. Wait, is Europe right? Yeah, pretty sure. Like this house is obviously European, but one isn't one the US? Oh, is the US? What? Is the US? Yeah, it is. Oh, what? I don't know. I'm on. Why did I think that was? Okay, but where in the US is this? Like, gotta be up here, right? Like, I'm just gonna go North Dakota. It was Canada. I don't know, man. That was a lot easier here. I mean, sign architecture probably puts us, and the Poles put us in Hungary or what? Is it Hungary? It's Hungary, right? Why are these Poles not? I've forgotten my Poles. Like I haven't, but like I have. Like I've had this pole. This is Hungary, right? I mean, I know it's obviously not Romania, but and it's not Bulgaria. It's not Cyrillic. It is Hungary, right? Why is the sun low-key north? Doesn't matter, but it is. It is Hungary. Am I missing something? It's not like Czechia, is it? Or like France or something. Like what? What? Oh wait, Loki, France makes sense. France makes sense. Oh, okay. France. Wait, does it? The roads, but the houses it makes sense for. Like, it's not a Hungarian house, is it? Man, I don't know. I'm going France. It was France. Okay. I was, I was really not sure. Like, thought I was tripping. But we're Southern Hemisphere, right? Yeah. Okay. Just making sure I'm not tripping. Always tripping on this map, I guess. It's I was playing rounds, yesterday, and it was not super hard. And suddenly they are. These Brazil polls, yeah? Assuming they are, because this is Brazil. Wait, why is the car looking red? I mean white. Why is the car looking white? Why is this low-key? Nah, it's not. It's not Colombia. The plates are not making sense for that. Oh no. Also, well, what's Southern Hemisphere? Like, none of Colombia would make sense. I don't know. But it's like, where is this? Obviously north, right? Or maybe not. Yeah, it's gonna be north. It's generally north. Okay, it was more south. Yeah. Could have probably figured that one out. Uh, we have Colombia. Where's this pole? It's Colombian, right? Yeah, I'll go Colombia, but probably east. Andes, like that. Ooh, Max North. Unlucky. And this is Japan or not? It's Japan, right? This is Japan. Yeah, it's not like Taiwan, right? Can make sense. Yeah, it's Japan. It is Japan. From this, I mean, can we tell anything? No. I mean, I would say it looks more south, but I mean, my guess didn't work last time, so I'm just gonna go middle. Okay. Slightly better, 17.3k. We'll take that. That's sort of score. I will end off there. Okay, that's all for today. We'll be back tomorrow with hopefully getting all of this done. So, carbonels and stuff actually done. Instead of, we did on Tuesday, which was just not getting it done. Okay, that's all. Goodbye.